Right now, you're moving through space at hundreds of meters per second, even though you feel completely still. Earth is carrying you through day and night without you ever noticing. But imagine that, tonight, something impossible happens. Earth stops. It simply stops rotating. The sun freezes in the sky. One side of the planet is trapped in endless daylight, while the other disappears into permanent night. And the terrifying part isn't that you'll lose your normal sunrise and sunset. Once Earth stops turning, the planet you know begins to die from both sides. The side of Earth facing away from the sun would lose something we normally take for granted almost instantly. Not for a few hours, sunlight forever. The sun would disappear below the horizon, and it would never come back. At first, it might not look very different. The atmosphere would still glow with scattered light, cities would still shine, and people would still have electricity. But the planet's surface would begin entering a completely different climate. Because without sunlight, Earth has no major source of heat coming in. And the first thing to change would be the temperature. The ground would begin radiating its stored heat into space. The oceans would do the same thing, although much more slowly because water can hold enormous amounts of heat. So this wouldn't be an instant deep freeze. Instead, the night side would cool in stages. The air would become colder. Plants would stop receiving the light they need for photosynthesis. Crops would begin failing. Animals that depend on those plants would lose their food, and the effects would move upward through the food chain. But there would be another problem: water. As the surface cools, moisture in the atmosphere would begin freezing and falling as snow. Rivers and lakes would start developing ice. Eventually, huge portions of the surface water could become frozen, and the colder the atmosphere became, the more water would leave the air and become locked away as ice. That creates a brutal cycle. Less water vapor in the atmosphere means less greenhouse warming. Less greenhouse warming means more cooling, and more cooling means even more water freezes. The night side would slowly begin losing one of the most important ingredients needed for life, accessible liquid water. But the oceans wouldn't simply freeze solid from top to bottom. That part is important. Ice floats, so when the ocean surface freezes, it creates an insulating layer between the brutally cold air and the warmer water underneath. The deeper ocean could remain liquid for a very long time, depending on conditions. That means the night side would not necessarily become a giant block of solid ice overnight. Instead, you could get a world with enormous frozen surfaces covering oceans, lakes, and land, while pockets of liquid water survive underneath. Life might not disappear completely. Some organisms could survive beneath the ice, around deep ocean environments, or in places protected underground. As the darkness continues, the problems become much more serious. The biggest one is food. Plants need light to produce energy through photosynthesis. Without sunlight, crops stop growing, grass disappears, leaves begin dying, and once plants start failing, everything that depends on them is affected. Herbivores lose their food. Then predators begin losing their prey. Even animals that can survive without plants directly would eventually feel the consequences, because almost every land food chain begins with something that needs sunlight. And unlike a normal winter, there is no warmer season coming to bring the ecosystem back. The darkness never ends. The temperature keeps falling. At first, humans could fight the cold with technology. Homes could be heated. Buildings could be insulated. Artificial lights could replace sunlight for some crops. But the scale of the problem would keep growing. Imagine trying to heat an entire city while the outside temperature is falling day after day. Every home needs energy. Every hospital needs energy. Every water system needs energy. Every farm needs energy. And if the power goes out, even for a short time, the consequences could become deadly. Then there's water. As temperatures continue dropping, rain would increasingly turn into snow, and exposed lakes and rivers would begin freezing. Eventually, huge amounts of Earth's accessible freshwater could become locked beneath layers of ice. The deeper the cold becomes, the harder it would be to keep water liquid. People would have to melt ice just to drink. And that takes energy too. So the same thing humanity needs to heat buildings would also be needed to produce food and water. That creates a dangerous chain reaction. Less energy means less heating. Less heating means more frozen infrastructure. Frozen pipes burst. Water systems fail. Buildings become uninhabitable. And once large numbers of people can no longer maintain their homes, entire regions could be abandoned. Animals would face an even harsher reality. Some species could survive by using stored body fat, entering dormant states, moving underground, or relying on whatever food remains. Others wouldn't have that option. Many insects would disappear. Many plants would disappear. And animals that depend on them would decline soon afterward. The result would not be one sudden mass extinction. It would be a slow collapse, spreading through ecosystems as one species after another loses the resources it depends on. And then comes something even stranger. The atmosphere itself would begin changing. As temperatures fall, more water vapor would freeze out of the air. Clouds would become less common in some regions. Snow and ice would build up on the surface, and the amount of heat trapped near the ground would continue decreasing. The farther this process goes, the harder it becomes for the surface to recover. And for humans, the psychological effects would be difficult too. You could build artificial lighting. You could create clocks that tell you when to sleep. You could make buildings that imitate a normal day. But outside, there would never be a sunrise. Never a warm morning. Never sunlight coming through a window. Just darkness. Day after day. Year after year. Eventually, surviving on the night side would require humans to live almost completely separated from the natural environment. Artificial light replacing the sun, machines replacing agriculture, heating systems replacing the natural climate, and enormous amounts of energy holding civilization together. But every year, the outside world would become colder. Every year, more water would freeze. Every year, more ecosystems would disappear. And eventually, the question wouldn't be whether humans could live comfortably there. It would be whether we could keep the machines running at all. Because while the night side is freezing, the other side of Earth is receiving sunlight continuously. And that creates an entirely different disaster. On the opposite side of Earth, the problem would be almost the exact reverse. The sun would never set. It would remain in the sky, continuously pouring energy onto the same regions of the planet. At first, this might sound like a paradise. More sunlight means more energy. Plants get more light. Solar panels can keep producing electricity. And people would never have to worry about darkness again. But the sun gives us something else besides light. Heat. And unlike a normal day, there would be no nighttime to take some of that heat away. Every hour, the same surface would continue absorbing sunlight. The ground would get hotter, the air near the surface would heat up, and water would begin evaporating faster and faster. The first major casualty could be something humans need every day: fresh water. Rivers and lakes exposed to constant sunlight would lose water rapidly. So would wetlands and reservoirs. The warmer the surface becomes, the more evaporation occurs. That extra water vapor would enter the atmosphere and change the weather. Clouds could form more aggressively in some regions, while other areas become extremely dry as moisture is transported elsewhere. Storms could become more powerful because the atmosphere would be continuously supplied with heat and moisture. And this wouldn't be a single heat wave lasting a few days. There would be no night to reset the temperature. Every morning, the surface wouldn't cool down. It would simply start from wherever the previous day left it. As temperatures continued rising, plants would face a strange situation. At first, extra sunlight might seem beneficial. More sunlight can mean more photosynthesis, but plants also need water. And once temperatures become extreme, leaves lose water. Soil dries out. Plants close the tiny openings they use to exchange gases with the atmosphere in an attempt to conserve moisture. Eventually, too much heat and too little water can shut down growth completely. So the forests wouldn't necessarily become enormous because they have unlimited sunlight. Many could begin dying from heat and drought. Agriculture would become especially difficult. Crops are designed to grow within certain temperature ranges. Water evaporates from fields. Soils dry out. Livestock struggle with heat, and farmers would have to spend enormous amounts of water just to keep crops alive. Hotter conditions mean more evaporation. More evaporation means more water is required. More water use means water supplies disappear faster. Eventually, some regions could become too hot to farm outdoors at all. Humans could move agriculture into climate-controlled buildings. But that creates the same problem we saw on the night side. It requires enormous amounts of energy, and the daylight side would need energy for something else too. Cooling, air conditioners would become essential, not just for comfort, but for survival. Hospitals, factories, homes, data centers, and power plants all produce heat or need protection from it. As temperatures rise, keeping large cities habitable would become increasingly difficult. And then the oceans would begin responding. The surface waters constantly exposed to sunlight would absorb huge amounts of heat. Warm water evaporates more easily, adding even more moisture to the atmosphere. That moisture can eventually condense into clouds and storms. So the daylight side could experience enormous cycles of evaporation and rainfall. Some places might be battered by intense storms. Others could become brutally dry. The distribution of water would become one of the most important factors determining where life survives. And the ocean wouldn't heat evenly. Deep water remains cooler than the surface, so strong temperature differences could develop between layers. Those differences would influence ocean circulation, marine ecosystems, and the movement of heat around the planet. But there is another reason the daylight side would become dangerous. The air itself. Warm air expands and becomes less dense. Cold air contracts and becomes denser. And now we have a planet with one side constantly being heated and the other constantly losing heat. That creates a permanent atmospheric imbalance. And near the hottest regions, the environment could become almost impossible for humans to tolerate outdoors. Animals would suffer too. Many species regulate their body temperature through behavior. They seek shade. They hide underground. They enter water. They become active at cooler times of day. But on the daylight side, there is no cooler time of day. The sun never goes down. The oceans might provide another refuge. Water absorbs and stores heat, so marine environments could remain more stable than exposed land for a while. But even the oceans have limits. As surface temperatures rise, marine ecosystems would begin shifting. Species adapted to cooler waters could disappear from the warmest regions. Coral reefs would be especially vulnerable to prolonged heat. And as surface waters become warmer, the conditions that support today's marine ecosystems could change dramatically. Meanwhile, the water vapor released into the atmosphere could amplify the greenhouse effect. Soil could dry and crack. Vegetation could retreat from exposed regions. Some rivers could shrink or disappear. Glaciers and permanent snow would retreat wherever conditions allow. Large parts of the surface could become deserts, but not necessarily ordinary deserts. These could be landscapes shaped by permanent sunlight, extreme heat, intense evaporation, and powerful winds. And while all of this is happening, civilization would be trying to keep functioning. Solar energy would sound like the obvious solution. Solar panels could generate electricity continuously. But they also have to survive the heat. Power systems need cooling. Batteries need controlled temperatures. Electrical equipment can fail when exposed to extreme conditions. And producing enough electricity to cool cities and run artificial farms would require enormous infrastructure, but increasingly limited habitable land. Water becomes more valuable. Shade becomes valuable. Cool air becomes valuable. Eventually, people might build enormous covered cities, underground settlements, or structures designed specifically to block sunlight. Imagine needing a roof over an entire city simply to create darkness. Human beings would be artificially recreating the night that Earth lost. And perhaps the most important resource wouldn't be sunlight or electricity. It would be temperature. Because if the night side is fighting to stay warm, the daylight side would be fighting to stay cool. One half of the planet is trying to escape the cold. The other is trying to escape the heat. And both are facing the same fundamental problem. Earth was never designed to have one side permanently facing the sun. But there's still something connecting these two extremes: the atmosphere, the oceans, and the movement of heat between them. Together, they would try to balance a planet that has been pushed completely out of its normal climate system. And that could create the strangest Earth humanity has ever seen: a frozen darkness on one side, a blazing daylight on the other, and somewhere between them, a planet struggling to redistribute the enormous amount of energy coming from the sun. Because when Earth stopped rotating, we didn't just lose sunrise and sunset. We changed the entire climate of the planet.